Hello engineers, it is great to see everybody again. I wanted to show you the project that I've been working on from home. This right here, engineers, is called a hydro-turbine, which means it can create electricity using the flow of water, okay? Now I want to talk about the different parts that we have. This right here, this is the energy meter, and this is the battery. So this can actually get electricity that's produced by our hydro turbine, and then it stores it in the battery to be used later, okay? Now, this cannot turn on unless something is providing it electricity, okay? Right now the battery is empty, there's no energy left in it. So for that screen to turn on, it has to have something that is inputting electricity to the energy meter, okay? And to do that, we're gonna use this hydro turbine. Now my hydro turbine has 6 blades, okay? And these blades, when the water hits them at just the right angle, it will actually spin the blades, which spins that gray axle, which is attached to that big gray gear. And then on top of that gray gear is a smaller 8-tooth gray gear, okay? So as I spin the hydro turbine, it spins the gray axles, which spins the big gray gear, which spins the tiny 8-tooth gear. Okay, engineers? And that 8-tooth gear on the top is attached to this, which is our turbine, okay? Now, if you plug this into the wall, you could turn it on and it would spin it around and around like a motor. But what we're doing is we're reversing so that instead of having the motor turn once you turn it on, when the motor turns, because the fan blades make it spin, then that motor actually produces electricity. That electricity travels through the cord right into the back of our energy meter right there, and then it can actually turn the screen of our energy meter on and it can produce electricity, okay? Hydro turbines are a really popular form of generating electricity. Okay, it's sustainable because all you need is the flow of water to turn it. So I'm going to show you exactly how this works, and then I'm going to show you some videos of other examples of hydro turbines. Okay, engineers? All right, engineers, so now we are going to test out our hydro turbine and see if we can create enough electricity in the turbine by making the gear spin to turn on our energy meter, okay? Now, I want you to think about different spots where water is flowing, okay, where you could put a hydro turbine. You can put them in a waterfall, you can put them in a river. There's even some technology where you can put them next to waves going in and out of the ocean to help create electricity, okay? Anywhere where there is water moving, okay? So you could even set one of these up underneath your rain gutter, and when it rains, all of that water comes out of the rain gutter really fast. You could set one of these up near your rain gutter and create electricity every time it rains, okay? But since it's a beautiful sunny day and it's not rainy right now, we're gonna test it out on our sink, okay? And you may be wondering what these sails are for, okay? And this is actually to make sure the energy meter and the turbine don't get any water on them, okay? Because they are electrical components and they're not waterproof, so these are shields to protect them from getting any water on them. Because of course, anytime you're mixing water and electricity, you want to make sure you take lots of precautions, okay? So I'm going to turn this on, full blast. All right, engineers, we are testing out our hydro turbine. Now, we don't have any rain because it's a nice sunny day here, but we're doing it using our sink, acting like it's a waterfall. And check that out, engineers. It is spinning fast enough to turn on our screen, and that lightning bolt right there, that means that it is charging up, okay? And if you look on the top left, it's saying that we have, looks like 1.9 volts that are coming in, engineers. So this hydro turbine is working. I don't want to waste any more water, okay? But imagine that this is a waterfall that is always, and watch what happens when I turn it off. The screen turns off, right? Because it has to have electricity coming in, engineers. So imagine that's a waterfall that's flowing all day, every day. Just how much electricity you could create, okay? All right, engineers and scientists, I want to show you a couple videos that talk a little bit more about how hydropower works, different types of hydropower, and some examples of some very old hydroelectric technology and some very new hydroelectric technology, because it's been around for a long time, okay? So I'm going to play a couple of videos for you.
Hydropower. Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydroenergy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators. The mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are two main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from dammed water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released. Some dams also contain an additional reservoir at their base where water is stored to be pumped to the higher reservoir for release when electricity is in demand. This is referred to as pumped storage hydro. The second form of hydroelectricity production is run-of-river hydro. Run-of-river still uses turbines and generators, but relies on natural water flow rates of rivers, diverting just a portion of the water through turbines. Because run-of-river hydro is subject to natural water variability, it is more intermittent than dammed hydro. There are various sizes of hydro plants that produce electricity. Large hydro, greater than 30 megawatts, small hydro, 100 kilowatts to 30 megawatts, and micro hydro, less than 100 kilowatts. The Hoover Dam in the United States is a whopping 2,074 megawatts, which is enough to serve 1.3 million people. Of all renewable energy sources, hydropower holds the largest share of worldwide electricity production.
So that's pretty crazy, isn't it, scientists and engineers, that hydropower, so electricity from water, that gives us more electricity than solar panels do, okay? So it can be really, really effective when engineers build it properly, okay? So now I want to show you an old, this one is hundreds and hundreds of years old, okay? This is a sawmill, okay? And the saw is actually powered using the energy from this water wheel, okay, or this water turbine. You can also call it water wheel. So now I want you to see just how cool this is, engineers. So you can see that that wheel makes that big long stick go up and down because we're connecting all these gears together. So that's what it looks like underneath, and then look what it looks like on top. It is connected to that saw. So every time the wheel spins around, that saw goes up and down. And then that is called a ratchet, which helps move the log forward very slowly. And then as the log gets moved, that's the... Look at that. How cool is that, huh, engineers? Okay, now I want to show you a newer form, okay, of hydroelectricity. This is called a vortex turbine, okay, and I want to show you how engineers build it, and then I'm going to show you of what one running actually looks like, okay? So they go right next to a river that's already flowing, and they dig out a little spot, and then they put in those, so it's like an extra track for the water to go down next to the river. And they open it up, so most of the water is still going down the river, but some of it goes off to the side. And then it makes it form into a vortex, which is like a water tornado. And that spins the turbine and produces the electricity. And fish can go through it, they don't get hurt. Some people ask that about rivers. Does it hurt the fish? It does not. Some people ask about that. It does not hurt the fish at all. And then this is what one looks like out in the real world. Look how fast the water starts going once they make it into the vortex. So just like in a tornado, wind gets faster and faster as it goes towards the middle. When you have water going into a vortex, it makes the water go super, super fast. All right, scientists and engineers, thank you so much for learning all about water-powered electricity with me today. I hope that you can think of some rivers or creeks or streams that you've walked past where you could add your own water wheel to produce electricity, or even power a saw to cut wood, okay? Once you're a little bit older, if we keep practicing building, then you can make amazing things just like we saw in our video today, okay? Have a great week, and I cannot wait to see you again.